Hello, my name is Ivan Taylor, and I would like to talk to you today about the value of mentorship in learning system dynamics. I'm from Ontario, Canada, and you can reach me at this email address, ivan@policydynamics.ca. As an outline of the presentation today, I want to begin by just saying, talking a little bit about the one-on-one mentorship program of the System Dynamics Society. And then I want to show you some videos about some of the challenges that some of my mentees face when beginning to learn System Dynamics. And these videos will also describe some best practices in building System Dynamics models. And then I want to go through a list of all the projects that we're working on, myself and the mentees, and just to show you the wide variety of applications that System Dynamics can be used for. And then I'll have some concluding thoughts. So let me bring up the first video, and it is called taking the mystery out of System Dynamics.
Hello, my name's Ivan Taylor, and I've been a mentor for a year and a half, and I've really enjoyed working with people to learn system dynamics. However, I feel that there's some misunderstanding, and that people coming into the field think that there might be something mysterious or magical about the way system dynamics works. So I'd like to show you quickly the way system dynamics works. So here's a small model with a population and an inflow of births and an outflow of deaths. So if I run this model and I look at the results, I can see here time moving in this column at a half a year at a time, and the inflow of births in this column, the outflow of deaths in this column, and the population in this column. So the way the population is calculated is that you take the value in the previous time step and you take the inflow minus the outflow multiplied by the time step and add it to the previous value. And now you have a value here of 100.5 after a 0.5 of a year. And then the next time step, you take the 100.5 and you take the inflow and the outflow and you multiply it by 0.5 and you get a new value for the stock. And basically, System Dynamics just walks through time, adding the inflow and subtracting the outflow times the time step to the stock. And there's really nothing mysterious about System Dynamics. So I hope this helps you get started.
Okay, and then second video I want to show is on probably the most important aspect of System Dynamics, and that is the importance of getting your units right in your calculations and in your formulas.
Hello, my name is Ivan Taylor, and I've been a mentor for about a year and a half, and I really enjoy working with people all over the world teaching the best practices of system dynamics. And one of the things that I've noticed challenges people starting out in system dynamics is the idea of units. So here is a small model that I built of the population of Canada. And we have an initial population of 38 million people. We have a life expectancy of 82 years. We have the deaths is the population divided by the life expectancy in people per year. And we have the births is the population times the birth rate in people per year. So now the question is, what is this birth rate idea? So if we look up the birth rate for Canada, we see that the birth rate is 10 0.3 people per 1,000 people per year. So this is people, the units here is people per year. And it's good practice to check your units every time you make a change to the model. So I'll check the units and it's okay. And if I run the model, I can look at the results and you can see that the population is declining. So this is a small model, but I just wanted to show you the idea of the importance of units and the importance of units checking each time you make a change to the model.
Okay, the next video I want to show you is about managing complexity in modeling, in system dynamics modeling.
Hello, my name is Ivan Taylor, and I've been a mentor for the last year and a half. And I really enjoy working with people all over the world, teaching the best practices in system dynamics. And one of the challenges I see that people starting out in system dynamics have is handling model complexity. And one of the reasons that models can get complex is that the software is very easy to use. Um, so here's a model that one of my mentees is working on, and he shows the whole model on one page, and it looks to me to be very complex, although he has done some work to manage the complexity by providing color codes for the various sectors in the model. But I would personally prefer my mentees to use a different approach to handling model complexity, and that is to use multiple views that are available in Vensim. So this is another model that one of my mentees is working on, and it's for the 17 United Nations Sustainable Development Goals. And he's got this model set up as 17 different views, one for each of the Sustainable Development Goals. And each of these views is connected to the other views through these shadow variables. So you have a stock for the Sustainable Development Goal, and then you have connections to the other Sustainable Development Goals through these shadow variables that are calculated on other views. And I think this is a good way to manage the complexity, both for the modeler and for the audience.
And the last video I want to show you today is an important idea that comes into good best practices, and that is a model calibration.
Hello, my name is Ivan Taylor, and I've been mentoring for about a year and a half now. And I really enjoy working with people all over the world, teaching the best practices of system dynamics. And one of the things that I found that often challenges people starting out in system dynamics is the idea of model calibration. So I just want to show you here in this short video how I was able to calibrate a small model. So here is the model, and it's a model of a small business that goes through a number of stages. And at each stage, we have to estimate the success rate, the continuation rate, and the failure rate. So we collected some data, and we can see here that the number of small businesses was growing up until 2008, and then there was a drop in the number of small businesses during the financial crisis, and then there was an increase after the financial crisis. So we decided that instead of modeling just a single failure rate, we would model two failure rates, one for the normal situation and one for the financial crisis. So I did this using, it's not the only way to do it, but the way I did it was I minimized the squared error between the model and the data by changing the failure rates. And this is the results of the calibration. And you can see that we got a good match between the data and the model. And that gives us confidence now to go back to our Vensim model and use these failure rates to project into the future. So if we look at the projections, we can see the historical data from 1994 with the financial crisis drop here, and then an increase up until 2020. And then if we assume that the COVID crisis leads to a drop in small businesses similar to the financial crisis, we might see a drop like this before it returns to normal. So here I hope this is helping you see the value of calibration in building confidence in your models.
Okay, so that was just four little videos that I did to describe some of the challenges and some of the best practices that I'm working with my mentees to develop. And now I want to go through just a list of the projects we're working on to show you the wide diversity of applications of system dynamics. So the first project is involving a dairy farm in Bangladesh, where the farmers are trying to collect and process dairy wastes and produce useful and beneficial byproducts, and thereby both improve the environment and get greater profits from their dairy farm. The second person I'm working with is involved in a pollution of a major river in Bangladesh, and he's trying to show the benefits of reducing the pollution and how that will improve the health and wealth of the people in the villages and cities surrounding the river. I'm working with two veterinarians, one from Canada and one from the United States, on applications for veterinary practice. I'm working with a person from Colombia and a person from Kenya on the impact of COVID-19 on trust in government. I'm working with someone from Costa Rica who is involved in the banking system and is interested in modeling financial risk. I'm working with a person in India and a person in Nigeria on small business clusters. And I'm working with these same people on the social, economic, and environmental impacts of oil mining and drilling. I'm working with a person from Iran on the COVID vaccination program there. And I'm working with someone from Nigeria on energy security, which is a particular problem in Nigeria, where the energy grid is just not very reliable. And then I'm working with another person in Nigeria who is part of the fledgling African Space Agency, and he was interested in the problem of growing amounts of space debris in outer space. And then I'm working with three people, Pakistan, Costa Rica, and Colombia, on institutional changes that can help in control corruption. And I'm working with the same fellow from Pakistan on institutional changes that can enhance economic growth. I'm working with someone from the United Kingdom on the gender pay gap. And that same person in the United Kingdom is working with me on the refugee crisis. I'm working with quite a few people in the United States, one person on climate change and the Catholic Church, another group of people on women of color entrepreneurs, another group of people on increasing diversity in organizations, and another fellow who's interested in the United Nations Sustainability Development Goals. And I'm working with someone in the United States on mealworm farming, and another person on water conservation in the western states of the United States. And finally, I'm working with a fellow in Zambia who is interested in cattle farming and trying to share best practices in cattle farming in various districts in Zambia. So just a few concluding thoughts. First of all, I think that mastering system dynamics is difficult. It's not easy to do, and that possibly classroom learning and self-learning may be insufficient to really master system dynamics. And what you need to do is you need to build many models yourself to really become a master of system dynamics. And a mentor can help you learn the best practices quickly and develop good practices for building models in system dynamics. So if you have any comments or questions, you can reach me at this email address, ivan@policydynamics.ca, and I'd be very happy to talk to you some more about the one-on-one mentoring program of the System Dynamics Society. I hope to talk to you soon. Bye-bye.